Section 4.6, congruence in right triangles. So remember, a right triangle is simply a triangle that has a right angle. And in that right triangle, the side that is across from the right angle is the hypotenuse, kind of the slanted side is the hypotenuse. And the other two sides are called legs. If you have a right triangle or two right triangles that you are trying to show are congruent, you can still use side, 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 angle, side, angle, and angle, angle, side, just like any other triangle. But there is also one more theorem that is special to right triangles only. The hypotenuse leg theorem. Shortcut or abbreviation is HL. And what it says is that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, the triangles are congruent. This section is pretty short, really. It's just the one theorem that we introduced. So we're going to just do one example. And it is just using some algebra skills to figure out what values of x and y make the triangles congruent by hypotenuse leg. So what values of x and y make the triangles congruent by hypotenuse leg? So when you're looking at two triangles and you recognize that they are right triangles, okay, try to identify which ones are the hypotenuse. So the hypotenuse of the triangle on the left is x, and the hypotenuse of the triangle on the right is 2y. So if these are going to be congruent by HL, the hypotenuse have to be congruent to each other. Which tells me that x has to equal 2y. And then the legs have to be congruent, so I'd have x minus 4 equals y plus 3. So x is by itself, whatever it equals can get substituted in for x in the other equation. So I'd have 2y minus 4 equals y plus 3. I have y's on both sides, right? So I want to get all the y's on one side. So I would subtract y from each side. And then I would add 4. So y would equal 1. So we have our value for y. plug that back in up here. X equals 2 times whatever y equals, which is 1, so x equals 2. So the values for x and y that make these triangles congruent by HL are x equals 2 and y equals 1. If you want to write them in the same place, you can. If you just want to square them off where they are, that's fine too. So set your hypotenuses equal to each other, set your legs equal to each other. Let's get this y by itself, so you'd subtract x. So you'd be left with y equals 7. So we already know what y equals. So then we're going to substitute it back into the first equation. So 7 plus 5 equals 2 times 7 minus x. So 12 equals 14 minus x. To get x by itself, remember, in front of the 14 is a positive, so we're going to subtract that. So I get negative 2 equals negative x. So if the opposite of 2 equals the opposite of x, we could just divide by a negative to get those positives. So 2 equals x and y equals 7.